4.4, number 158. We have the function y equals tan pi on 4x, specifically over the interval -3/2 to 3/2. We're supposed to show, sorry, not show anything, we're supposed to estimate. Estimate the number of points C. Estimate the number of points C such that the mean value theorem holds, basically. Such that f prime of C, they write it without the quotient, f prime C times b minus a equals f of b minus f of a. Now in these problems, certainly this is a and this is b in these contexts. Okay? And of course y is the, I mean that's not a question, y is the function. Okay? So they want us to graph it to figure this out. It has a technology symbol bias. That means with a calculator. And I'm going to just draw by hand instead, maybe. So let me just do this. It's not that difficult of a graph to draw, I don't think. So let's see if we can do this. Since the argument inside the tan function is pi on 4x, that means the new period for this function is, of course, the old period, pi, divided by the coefficient on x. Again, tan's normal period is just pi, not like sine and cos, which is 2 pi. So pi by pi on 4, we get 4. So the new period is 4. So we should expect to see over the interval -2 to 2, right? Because that's an interval 4 long. So maybe we'll make this -1 here, and -2 here, and 1 and 2. So there's one fundamental period of this tan function. We know the asymptotes will be out here now instead of what they were before, which was at -pi on 2 and pi on 2. They've changed locations. The basic structure is the same as you've seen many times for that tan function. Something kind of like this. Maybe something like that. So now over here at -3/2 and 3/2, right? Let's up a little bit. -3/2 and 3/2. -3/2 is -1.5, so right here, and then map that down to the curve, maybe there. 3/2 is here, 1.5, and map it up to the curve there. And if I draw a secant line between these two, as best I can here, to illustrate. This function is odd, so it has to pass through the origin to get to this other point here. Okay, it's not perfect, not a perfect looking picture, but it's reasonable enough. There's our secant. Okay, that's our average. That's our line that has the average rate of change on it. Its slope is the average rate of change of this function. Now I'm just looking around to see if on this same interval, from -3/2 to 3/2, on this interval, are there any locations where the curve has the tangent line with the same slope? Well, you can probably guess maybe around here somewhere. Right, if I drew a tangent line there, it's a reasonable looking parallel to that. But since this is an odd function, you should have another one over here if that's the case. If you find one on this side, there should be another one on this side for these odd functions. And this picture is not perfect, but I hope it gives you the main idea of how to approach a problem like this and what they're looking for, right? There's a couple places. Again, you don't have to know where they are. You just have to estimate how many there are on this interval. And by estimating, it looks like 2, right? So our answer would be 2 for how many locations there are that satisfy the mean value theorem on this particular interval.